Welcome to The Explainer. Today we're exploring a massive leap forward in critical infrastructure safety. We're looking at how advanced AI is shifting our defense mechanisms from a passive weeding game to proactive algorithmic intelligence. If you work around high-stakes environments, you know that when an emergency strikes, literally every single second dictates survival. So we're going to break down exactly how next-generation systems are completely rewriting the timeline of fire detection. Think about it for a second. What is the silent, fatal flaw in modern fire safety? When most of us think of fire prevention, we just picture a standard smoke detector mounted on a ceiling somewhere. It's something we walk under every single day without a second thought. But I want to expose the hidden, highly dangerous flaw hiding right there in plain sight. The systems we currently trust are almost entirely reactive. Consider the difference between the traditional wait-and-see approach and a modern active interception model. By the time dense smoke actually rises, fills a standard sensor, and finally triggers an alarm, the fire has already taken hold. The damage to your server racks, your heavy machinery, your critical infrastructure, it's already done. And worse, toxic gases are already spreading. In high-stakes environments, waiting for the fire to literally come to the sensor is a losing strategy. That's exactly why we absolutely have to shift from waiting for the fire to actively intercepting it. Here is our roadmap for today. We'll start by breaking down the fatal flaw, move into the predictive layer of beating the spark, then look at preventative autonomous cross-checking, reactive precision mitigation, and finally wrap up with the ultimate strategic edge. Let's jump right into Section 1, the fatal flaw. If you think about the actual timeline of a fire's development, heat and invisible gases start appearing way before we ever see smoke particles. The legacy trigger point doesn't even activate until the smoke is thick enough, but by using advanced edge AI, modern systems are integrating atmospheric data right alongside heat signatures. This shifts detection entirely into proactive, pre-fire analytics. We're basically catching the threat in its infancy. The difference in architecture here is night and day. Legacy setups rely on a really simple threshold principle. They're basically just waiting for a specific physical trigger. That makes them incredibly reactive and super prone to false alarms from things like dust or steam. On the flip side, modern AI systems use pattern recognition. They give you a predictive early warning and filter out those false alarms through multi-parameter correlation. We're essentially moving away from dumb sensors to proactive algorithmic intelligence. Moving right along to Section 2, Predictive, beating the spark. Instead of waiting for thick smoke, modern frameworks create what's known as an invisible diagnostic layer. This continuous AI tracking uses table and connector heat monitoring paired up with thermal cameras. It operates on a really simple principle: knowing before it burns. It is constantly mapping the thermal profile of your space. So the absolute second an unnatural temperature anomaly occurs, this system knows about it long before combustion is even physically possible. The crucial takeaway here is that this predictive advantage gives you unprecedented power. By continuously tracking electrical panels, keeping an eye on server rooms, and watching heavy machinery, the system identifies critical hotspots and electrical overloads well in advance. And why does this matter? Well, intercepting an overloaded wire before it ever sparks can save your entire data center from a catastrophic outage. You are effectively stopping the fire in the future. All right, Section 3, Preventive, Autonomous Cross-Checking. So, what happens when an early anomaly pops up? The system doesn't just sit there and wait for a human to go check it out. It uses a revolutionary two-stage autonomous mechanism. Imagine step 1. A specialized CCTV camera spots a trace of smoke or a sudden heat spike. It instantly pushes a real-time pre-alarm to your application. But here's where the magic happens in step 2. At the exact same time, it instructs neighboring smoke, carbon monoxide, or gas sensors to drastically lower their own detection thresholds. Machines are literally talking to machines, dynamically adjusting their sensitivity to confirm the threat at lightning speed, all without needing a human to verify it. To completely eliminate false positives, the system relies on a really smart 3-layer logic funnel. At the very top, AI-based hotspot mapping uses thermal imaging cameras. That funnels down to visual pattern recognition via optical cameras, actively ruling out things like dust, steam, and vibration anomalies. Finally, advanced addressable alarms use multi-criteria detectors to pinpoint the exact location. This collective decision-making ensures that when the alarm finally rings, it's an absolute fact, not just some system glitch. Next up is Section 4, Reactive, Precision Mitigation. When you bring it all together, this integrated multi-sensor architecture is incredibly powerful. You've got all these diverse inputs: smoke and heat detectors, thermal and optical cameras, gas sensors, and they're all funneling massive streams of data directly into a central brain. This embedded edge software platform powered by NVIDIA does all the heavy computational lifting locally. That ensures absolute zero latency when making those life or death decisions to trigger general alarms and flashers. Because literally every single second matters in a verified emergency, this panel ruthlessly bypasses human delay. It automatically confirms the fire and sounds the alarm instantly. But more importantly, it triggers targeted mitigation protocols. It'll autonomously shut down gas lines, it will dynamically isolate specific electrical zones to starve the potential fire of energy. It's mitigating the disaster with surgical precision before a human operator even has time to pick up a radio. Finally, let's zoom out for Section 5, the ultimate strategic edge. There's a great thought that really summarizes the reality of implementing this tech. It doesn't ask you to choose between your existing infrastructure and next-generation AI. The true power of this system is that complete lack of compromise. It seamlessly fuses the traditional, dependable fire alarms you probably already have with a cutting-edge, thinking network of CCTV, thermal, and gas integrations. It protects your assets completely, asset by asset, second by second, creating one unified shield. As we wrap up this explainer, I really want to leave you with a provocative thought. Knowing how impossibly fast a modern threat can escalate, how proactive is our critical infrastructure really? We've seen today that simply waiting for smoke to fill a room just isn't an option anymore. I hope this deep dive inspires you to look at those everyday sensors sitting quietly above your head in a whole new light, and pushes you to demand safety systems that think, predict, and protect before the fire even begins.